So this video discusses some of the basic concepts behind working with disconnected data. So the whole idea about working with disconnected data is that if you don't have a connection, that your edits that you make are cached and then pushed back to the server later on when you do have a connection. So in this particular case here we have a simple case. We just have a single customer list. But you can also deal with hierarchical data. So basically the list in effect represents an in-memory database that you're updating, and then when you have a connection, then you push the edits that you've made to this in-memory database that is represented by the list back to the server. So this is just a simple list here with customer information. But if we go here to this component, you can see that we have a more complex set up here where we have a list of customers, and then in this list over here we have the orders for the customer that has focus, and then in this list we have the order items for the order that has focus. So you can see that as I navigate from customer to customer to customer, the data in the orders list is updating, and then as I navigate from order to order to order, the data in the order details list is updating. So all of the data though that is represented by these lists is in memory, so there's no callback to the server at any point in time to go and get data as I'm navigating from record to record. So let's go back now to the simple case and look at the various options. So here we have it. You can see that here's the list which represents the in-memory data, and then on the right hand side we have what we call the list detail view, where the information for the current row in the list is displayed. Now the list itself can have retrieved a lot more data from the server than is being displayed. So right now I'm displaying several columns, but I might only, for example, just display, say, first name and last name in the list so that I can quickly find the row that I want to edit. But then when I click on the row, this detail view can display a lot of information. So it can display columns that were retrieved from the server but aren't necessarily displayed in the list. So let's go now, for example, to this first row and make an edit. Change that to Jones, and then change that to, say, LA. And now when I hit the save button, you can see what happens is the row gets marked as dirty. So the data has not yet been pushed back to the server. We've just saved it locally, and because I've got debugging turned on, I can actually see what is saved in the in-memory database represented by this list over here. So now let's go to a second row here and make an edit over there and type in, say, Nora, and then go here and change that to Cecilia. And now you can see that we've got 3 rows that have been edited. And let's go now and add a new row. So I'll go here and I'll type in, say, Adina Smith, Boston, and we'll put you in California, and then hit the save button. So now you can see that we've got a blue row over here to indicate that this is a new row. So at this point now we've made 4 different edits. We've made 3 updates and 1 insert, but we haven't yet pushed anything back to the server. And you'll notice that the synchronize button now has become enabled. So this little text box over here allows me to simulate what's called the batch size. So when you push data to the server, you can decide what your batch size is, the number of rows that you want to push at a time. So the reason that you'd want to do that is so that you could possibly display progress to the user as the batches are being updated. So typically this would be used if you maybe had, say, 100 rows or 200 rows that had been edited while you were away, and you want to submit, say, in batches of, say, 10 or something like that. So let me pause now because I'm running out of time, and pick it up in the next video. So continuing now, so we're talking about the batch size, and another reason that you would want to have to be able to set the batch size is if you're submitting a large amount of data, you want to break the job into smaller pieces so that you don't get any type of timeout on your callbacks. So right now I've set my batch size to 1, which would be typically an unrealistically small batch size. But when I hit the synchronize button, you're going to see showing up over here a progress bar that shows the progress as this data is being pushed back to the server. So you can see when I hit the synchronize button there, you saw a little progress bar come up that showed the progression as those batches were submitted, and since there was few records, it went away pretty quickly. But there was also an abort button that allowed me to abort that. So all those records have now been pushed back to the server, and you can see that the little marks that indicated that those records were edited have gone away now because the data has been pushed back to the server. So now let's go ahead and see what happens when there are errors. So let's go now to this row over here and type in, say, a value that is too big to fit into the database. So this is clearly going to be an error. And now when I hit the synchronize button, you can see that what happens is we get back an error immediately telling us that the row was not updated over here. And now the row is still marked as dirty, so it's still got the little yellow marker over there. Now these markers can be customized through CSS, but so right now we've just chosen yellow to indicate that the row has been edited, and now the red indicates that there was an error when we made an attempt to synchronize this row. So when we click on the row, you can see that the error for the row shows up. So it's wrapping onto the other line there because I don't have enough space. So if I just make my screen a little bit wider here, you'll see it doesn't wrap. So that when I give focus back to that row, I can see there that what the error message was. So there, for example, was a row that could not be updated. So let's go back now and change this to, say, San Francisco, and then hit save, and now synchronize, and now the record basically is successfully saved. So that's one type of error that you can get. Basically, that's an error that was a so-called database error, and in other words, when we actually tried to update the database gave us back an error. Another type of error is called a synchronization error or a write conflict error. So for example, let's say we have this record over here that says Nora Pold, and I'm going to go now and edit this and change this to, say, Jackson, and then save it. So now I've saved this record locally, but I haven't yet pushed it to the server. So now I'm going to go to the server and go to that record Nora Pold, which is, let's just refresh this and make an edit here and change this to so in other words, what's happening now is somebody has gone to that record, and while I was working in a disconnected mode, someone else has gone and edited that record. So now when I try to synchronize my changes, so you'll see now I hit the synchronize button, and now I get an error. Basically, it's a write conflict. So this is telling me that I'm not able to save this record because somebody else has already changed the record. So you can see again this goes red here, but this is, in this case, it's a different type of error. This is a write conflict now, and so we get a little message here telling us that we couldn't save this record because there was a write conflict. And now if I tap on that, it says, well, you can resolve this conflict in one of two ways. You can either basically accept the value that's currently on the server, and if I do that, so let me just actually pause here because I'm running out of time again. So talking about write conflict resolution. So now if I tap here, you can see that I've got two choices. I can either use my value, Jackson, which means that the record will then go back to being dirty but with no error on it yet, because I'll have to resubmit the data to the server. Or if I use their value, then the record will no longer be dirty because it'll just be updated with the current value on the server. So let's go back here and start out. First I'll just choose use theirs. So now I'll choose that, use theirs. So now you can see that the record is no longer dirty because I've just accepted the value that's currently on the server. On the other hand, let's go now back to the server and let's refresh that data there. And now I'm going to go here and change this to Harris, and then go here and type this to Johnson, and then save, and then synchronize. So again I get a write conflict, but this time I'm going to say no, use mine. So you'll see that what happens is the record is still marked as dirty because I've now got to submit my changes again, but it no longer has an error marker on it, and now I can go synchronize, and my submission was successful this time. So now if I go back to the server and look at the data, I'll see Johnson in that record after I refresh it. So currently it says Harris. I go here and do a refresh, and now it says Johnson. So basically that showed how write conflicts are resolved. So another thing that I want to point out is that you can see here that every time I edit a record, so there we go there, so save that, and then go there and save that, and then when I hit the synchronize button, you'll see that actually it happened so quickly there, but there at the top of the corner you saw the what's called a fade out message. So I'm going to go back there and edit that again, hit save, and then just scroll up a little bit so I can see it. So you can see there's record was saved. So that's called a fade out message, and the user can basically completely customize the text in the fade out message with their own XBasic. So I haven't shown actually how the user sets up all of the disconnected stuff. I'm just showing how it's working in how it actually works once it has been set up. So now that we've kind of gone through how it all works for a single table, as we've shown over here, let's go take a look now at hierarchical data. So with hierarchical data, basically edits can be made obviously at any level in the hierarchy. I could make an edit in the customer list, in the orders list, or the order detail list. So let's go here, for example, to this record over there and make an edit. I'll go here and I'll change that to 55 and then hit save. So you can see now that what happens is this row gets the orange marker to indicate that it's dirty. But what happens also is that this row's parent record also gets marked as dirty, but it gets marked with a light orange to indicate that it's not this row per se that is dirty, but its child that is dirty. And then similarly, this row, which is the parent of this row, also gets a light orange to indicate that it's dirty, but it's not dirty itself. One of its children is dirty. So now let's go, for example, and make a change over there, make that 3. So now we've got 2 dirty rows in order details, but still this is just marked as light orange. Now I'm going to go to this row and make an edit over there and then hit save. So now you can see that this has now gone from light orange to dark orange to indicate that not only does this row's 2 children have edits, but it also has an edit in it. So I have to pause now and pick this up in the next video. So continuing now, you can see now that we have dark orange in the orders and all order details, because this row now has an edit directly at its level. So, but the customer record still is showing light orange because we haven't edited this record per se. We've only edited one of its children. But if I go now to, say, Mexico and change that to Mexico 2 and then hit save, you can see now this has gone to dark orange. So at this point now, if I were to press synchronize, so let's go ahead and hit the synchronize button, and you can see here in my fade out message it just says record was saved. So even though physically we edited 1, 2, 3, 4 different records, what counted was, this counted as one single logical record. So the customer, all of its orders and all of the order details for all of its orders count as a single logical record. So if I were to go here, for example, and make an edit over there, and then go to, say, the next record and make an edit over here, let's go make that UK2. So now you can see that we've edited 2 different customer records. So now if I hit my synchronize button over there, it says 2 records were saved, because what we count is the number of logical records that were done. So in the same way that we use dark orange and light orange to indicate whether the row is dirty or a child of the row is dirty, we use the same concept for errors as well. So if I were to go, for example, to that row over there, and let's now edit this row and type in a value that is clearly too big, and then go ahead and hit save. And now when I try to synchronize that, you can see that what happens is we get a dark red over here to indicate that this row has a real error in it. On the other hand, you can see here we have light red to indicate that there's an error somewhere, but it's not in this row per se, it's in a child of this row. And similarly, you can see there's a light red over there. So the reason that the light reds and dark reds are useful is if I was looking at this list right now and I could see, oh, there's an error over there, so I'll put my I'll give focus to that row, but nothing shows up over here as being as having an error. So I know that I need to drill down to the child of this list. So if I go to the child of the list, I can see, oh, it's this row that has the error, although when I click there, there's no error per se showing up. And then if I go down to the to its child, I can see, oh, this is the row that has the dark red on it, and there's the actual error showing up over there. So it tells me that the record was too big. So the ability to deal with disconnected hierarchical data is important, because in a lot of real-world applications, data is hierarchical. You have, say, customers with orders, or students with classes, or classes with students in them, or most data is hierarchical in applications. So dealing with the hierarchical data in this fashion makes it very visual, as to to see where errors took place, etc. So I think this gives a pretty good top-level overview of how disconnected works. Thanks, Adina.